Next problem is called palindrome linked list. We are given a head of a single linked list, and we have to return if it's a palindrome or false otherwise. A list is a palindrome basically if the sequence of the elements from the left to right of the node, from head to tail, is the same as the sequence of the node values from the tail to head. So in this case, we have from head to tail, we have 1, 2, 2, and 1. But from the tail to head, we have again 1, 2, 2, and 1. So basically, these two elements match, and these two elements match. So the list is a palindrome. The second example is 1 and 2. Basically, the elements are not matching. The from head to tail sequence will be 1 and 2. From tail to head sequence will be 2 and 1. And these are not the same. So it's not a palindrome. We have to return false. The number of nodes in the list is in range from 1 to 10 to the 5th. So we're kind of looking for linear time complexity solution, and the node values are from 0 to 9. Now there's here also a follow-up. Can we do it in linear time and constant space complexity? Basically, to solve this problem, it would be enough to check if the second part of the linked list after the middle element is reverse order of the first part. Because if it's a reverse order, we will have the same sequence from the start to end to the start. So in this case, we have 1 and 2 and 2 and 1. So we know that the second part is the reverse order of the first part. To do this, we can use a stack data structure, because stack is basically last in, first out the structure. So if we iterate over the first half of the list, we will place the node with the value 1 in the stack, and then the node with the value 2 in the stack. And then for the second part of the list, we will be just reversing it, and we will be popping the elements from the top of the stack and checking if they are the same as the second part. And in this case, we will have 2 matching 2 and then 1 matching 1. So we know that the list is a palindrome. But now we are having linear space complexity. We are not having constant space complexity. We could probably do better. To solve this problem, we will be using two approaches that we have already used to solve the two problems in the linked list category. The first one is the reversing of a linked list, and the second one is to find the middle of the linked list. So if you reverse the second part of the list, and to find the second part of the list, we will basically be searching for the middle element, which we already know how to do. Once we find the second part, we will basically reverse that second part, and then simultaneously we will iterate over both halves of the list and be checking for equality. So after we have find the second part and we have reversed it, it will become 1 and 2. So 1 connecting to 2, not 2 connecting to 1. And then we will place one iter at the beginning of the first part and the second iter at the beginning of the second half. And we will be checking for the equality of the node value. So in this case, we have 1 and 1 is equal. They are both equal, so we are good, and we are moving to the next element as long as we have elements in the list. In this case, now the first iter will be pointing to the second element in the list, and also the second element will be pointing to the second element in the second half of the list. In this case, we have 2 equal to 2, so basically we know that those values are equal, so we can proceed, and we are at the end of the list, so we know that they are palindromes. So the 2 steps for this problem is to basically find the middle element, and then use that middle element to determine the second half of the linked list. Reverse that second half of the linked list, and then simultaneously iterate over both halves and check for equality. If at any point we find elements that are diverging, basically that are not the same, we know that the two halves are not in reverse order. So that means that we don't have a palindrome, and we can just return false. Because we are not using any additional data structure, we will have constant space complexity. So first, we know that the minimum number of elements that we have is at least 1. But if it's 1, then there is no sense to perform the palindrome function. Basically, every list that only contains 1 element is a palindrome by itself, so we just return true by default. Next, we will perform the finding of the middle middle node in the linked list, and we already know how to do that. We point the slow and fast pointer to the head, and we move the fast two nodes at a time, and we move the slow one node at a time. As long as we don't reach the null element or basically the last element in the linked list by the fast pointer. At that time, the slow will be pointing to the middle element or the second middle element if the number of nodes in the linked list is even. We also have this little addition, which is the previous pointer. The previous pointer will always point to the element before the slow pointer. And we will need this because we will basically need to break the two halves so we don't have an infinite loop. Because think about it, if we iterate over the two halves, we have to know when to stop, and we know when to stop when we basically reach the null element. But if the first half is still connected to the second half, then we will basically have we will return false, and we have to return true, for example. So we will have a faulty result. So basically, we will to disconnect them. We will just put the next element to the previous to be equal to null, and slow will be now pointing to the second, to the middle element, and also the first element of the second part of the original linked list. Then we will create an iterator that will point to the first element in the first half, basically the original head of the linked list, and the second iterator will point to the reversed list. The reverse second part of the list. And so we'll call our reverse list function, and we'll propagate the slow pointer, which is basically the head of the second half of the linked list. Then we will move the iter1 and iter2 simultaneously, as long as both of them are not equal to null. And for each iteration, we will check if the values that the pointers are currently pointing to are equal. If they are not equal, we'll just return false. Otherwise, we will continue iterating, and we will just move both pointers to the next element in each of the halves of the list. Finally, if we traverse over all the elements in both of the list and they are matching, we just return true. Next, we also have our reverse list function that we basically just copied from our problem reverse linked list.